Welcome to my channel. The last video we have seen the main introduction of graph, what is graph data structure and what are the main important component which defines the graph. All those things we have explained, and also we have explained the real time example of graph, okay, which easily explains what is graph actually. Okay, if you haven't watched, please watch that video and come back to this video. In this video, we have the next part of graph which explains the terminologies. I can say that we are going to explain the graph terminologies. What are the important terms we use to include in the graph? Okay, in the upcoming videos, we used to use these terms. If you are familiarized with these terms only, we can able to move forward to explain or to understand the graph data structure. The first and foremost important term is adjacency. Okay, adjacency, which means that I'll just write. So here the first important term which is very important for your understanding regarding graph, okay, the adjacency. Okay, the first important term which frequently we use in the graph is adjacency. Okay, so here this particular term is defined when your vertex is said to be adjacent, okay, to the another vertex. So which we have seen before, okay, and a diagram here. So where yeah, I just take one graph here. Okay, so we just gone through some graph in the last video. I'll just take one simple graph, so which explains you these concepts very easily. So we have a data, the 0 and this is 1 and this is 2. So this is a simple graph I have taken for your understanding for this explanation purpose. So in this, your vertex is said to be adjacent to another, okay, if there is an edge connecting to them. So adjacent is nothing but the neighbor vertex. For example, the adjacent vertex of 0 is 1 and 2. So when I have one more vertex 3, okay, so here there is no direct link between 0 and 3. So the 3 will not be under the adjacent vertex list of 0. So when you just taking adjacent vertex of 0, I will be having only 2 nodes or 2 vertex, which is nothing but, okay, 1 comma 2. So where you have a direct edge, okay, from that node, okay, whatever the nodes is directly connected to this, those are the adjacent vertex of the particular vertex. So here the 3 is not directly connected to 0. So the 3 is not added in the adjacent vertex list of 0. So when I am taking the adjacent vertex of 1, what are the adjacent vertex of 1? So for this one, I have 3 nodes are directly connected. So I can say 0, 2 and 3. So the 3 nodes are directly connecting. So the adjacent vertex of 1 are 0, then 2 and then 3. Okay, so these are the adjacent vertex. So the neighbor vertex, so where you have a direct link or edges that connect between 2 nodes. Okay, so that is called adjacency. Next, we'll move on to the next important term, path. Path is nothing but a sequence of edges that is from vertex A to B. Okay, so when we say that, okay, I have a path 0 to 3, I have a path. I can say, I could not say that the 3 is in the adjacent vertex, but I can say that there is a path exists from 0 to 3. Path is nothing but I can just traverse, or I can travel from 0 to 3 through 1. Okay, I have a path. Okay, so in this case, I have 0 to 1, 1 to 3. Okay, if I have the graph in this way, in this representation, I have a graph like this. So I have 3 over here. This is my 3 and I have 1. Okay, this is my graph. So there is a path exists from 1 to 3. It is not even connected directly, but I can just reach their destination. I can reach this vertex through 0 and 1. There is a path established between 1 to 3. Okay, so this is the definition of path. So I can say that the sequence of edges that allows you to go from one vertex to the other vertices. Okay, so from 0 to, I can say that to reach 3, I have to traverse from 1 to 0, then 0 to 2 and 2 to 3. So this is how you have a path. So adjacent vertex is different from the path. Adjacent vectors are nothing but where we have a direct edges, those are called adjacency, and path is nothing but a sequence of edges which makes you to travel from one vertex to the other vertex. Okay, sequence of edges. So see, from this I have one edges, again I have, from this I have one more edges, I have other edges. So I have to take 3 edges to reach from 1 to 3. That is called sequence of edges. The third one is directed graph. So directed graph is like when we have a directions in the graph, then I used to say the given graph is a directed graph. Okay, so here the graph in which an edges, okay, does not necessarily mean that there will be an edge between u comma v as well. So when we have a direction, so by default it is a bidirectional, so I can just travel from 0 to 1 and also from 1 to 0 if you are not giving any directions. That is called undirected graph. When I have given a directions like this, okay, when I have given an arrow mark, so which means that there is only one direction. So from 0 to 1 only I can travel. I could not able to travel from 1 to 0. There is no path exist from 1 to 0, but there is path exists from 0 to 1. So the arrow mark indicates that the path travel from the vertex to the other vertex. Okay, this is nothing but your directed graph. When you do not have any direction, then that is called undirected graph. So these are the important terminologies. So the adjacency is nothing but the when we have a direct edges from the current vertex to the other vertexes, then that is called adjacent vertex. Path is nothing but a sequence of edges that take up to from one vertices to the other vertices. Okay, and directed graph, when we have an arrow mark at directions which represent that edges will be like indicated by the arrows, so that you have directions of path, okay, from which path you have to travel from one vertices to the other vertices. So these are the 3 important terms we have to use to understand the graph data structure. Okay, so now we'll see like how to represent this adjacency and then path, all these things. Okay, so now we'll see the graph representation. Okay, so regarding the graph representation, first let's see adjacency matrix. How to construct an adjacency matrix from the given graph. Okay, before moving into an solving or constructing a matrix, adjacency matrix for this graph, we'll see that how do you define an adjacency matrix. So actually this adjacency matrix is a 2-dimensional array, so which has V into V. So this is your array actually, vertex by vertex. So V by V vertices. Okay, each row and column. Okay, so this is your row and this is your column. Each row and column represents your vertices only. Okay, every column and row will be representing a vertices. So here, if the value of an element, so will be like for 2-dimensional array, we used to have I and j, which is nothing but I is your the row and the j is the column. So when we have I, A, I, j, okay, so when we have a 2-dimensional array, so with rows and columns, we told you already that, okay, both rows and columns are vertices only. So this I represent vertices and j represent vertices. When ia, ij is equal to, okay, is equal to 1, which means that it represents that there is an edges connecting the vertex A to vertex j. Okay, so if if the values of this particular matrix, or this will be array, the matrix of or 2-dimensional array will be only 0 and 1. If this A, I and j is 1, then there exists an edges from this vertical to this vertex. Okay, if you are A, I, okay, if you are A, I and j, okay, so both are vertices only. So when you have these values as 0, which means that we do not have any edges connecting these 2 vertices. Okay, so only 2 values are possible in this 2-dimensional array or adjacency matrix. So when we are representing one, or when we have an edges, we have to mention that when we have this, for example, if we consider these two vertices 0 and 3, when we have edges, we have to represent the value as 1. When you take 2 and 3, there is no edges between 2 and 3, so we have to represent the value A array 2 and 3 is equal to 0. This is how you have to construct a array matrix or adjacency matrix. We will see like how to construct an adjacency matrix for the given graph. First and foremost, what you have to do is you have to construct an array, okay, two-dimensional array. So we will be like drawing an array table here, okay, with the rows and columns. So how many vertices we have? 1, 2, 3, 4 actually, okay. So we will be having 4 rows and 4 columns. So we will be just draw 4 rows, okay. So 0, 1, 2 and then 3. Okay, again column is also 4, so we will be like V by V, so where which 2 vertices actually, so 0 and 1 and 2 and 3. So totally we have 4 vertices, so in that regard we have just drawn the table 4 by 4, okay, the array is 4 by 4. So which means that V by V now becomes 4 by 4 because we have 4 vertices in the given graph. So we have just drawn the 4 by 4 matrix table. So we will be representing this I as 0, then 1, whatever the vertex you have to write that. If you are given A, B, C, then you have to write A, B, C. But here in this graph the data is 0, 1, 2, a numerical data. So we will be like giving that numerical data here. So 0, 1, 2, 3, again you have to write. The column is also a vertices 0, 1, 2 and 3. So now this is your Aij, this is your I, okay, this is your I and this is my J, okay. So this particular columns are J and this particular rows are I. So what we seen before, when we have Aij equal to 1, then there exists an edges between the vertex I and J, okay. Now you see, now it is A0, the A0, which means that I have row as 0 and column as 0, okay. So I have A0 and 0. You have to see that whether you have an edges connecting these two vertices. So I have only 0 here, so both are 0, there is no edge among itself. So there is no edge means we have to write as 0, okay, you have to give the value 0. Then you have to, first you have to take this row 0 and you have to match with all the columns. Now only J changes for this row, and what is the value for 1, okay, this becomes 0, okay. When your row is 0 and when your column becomes 1, okay, is there any edge is connecting, okay, is there any edge is connecting 0 and 1, okay. When you have an edge connecting 0 and 1, you have to see that. So we have an edge connecting 0 and 1, so there is a edge, so we have to give it as 1. So just give it as 1. Okay, which means that when you have the vertices as neighbor to this 0, just give 1, that's it. Neighbor means there is a direct edge connecting to this particular thing. You see now 2, take 2, is there a direct edge connectivity to 0? Yes, it's there. So then give 1. Then take 3, see that there is a direct connectivity to 0? Yes, there is a direct connectivity from 3 and 0. So just give 1, that's it. This is how you construct a adjacency matrix for a given graph. Now your row changed to, now the value of row changed to 1, okay, and the column starts from again 0 to 3. So now you take the row 1, so now you are taking 1, so the column is 0. So is there any edge connectivity from 1 to 0? Yes, there is a edge connectivity from 1 to 0. You see whether it is the directed graph or undirected graph. When it is the undirected means there is no arrow is given. When it is undirected, then by default the edge is a bidirectional edge. So we can just come from 0 and also from 1 to 0 we can go. It's a bidirectional. So I have a edge connectivity from 1 to 0. So then I will give 1. Okay, now from 1 to 1 there is no connectivity, so I will just give 0. And again from 1 to 2, then there is edge, I will give 1. Now see, for 1 to 3, I do not have any direct edge from 1 to 3, so I will give 0. Okay. Now I will just take 2, from 2 to 0 I have a direct connectivity, so I will just give 1, and then again 2 to 1 I have direct connectivity, so I will just give 1. Again for 2 to 2 I do not have any connectivity, so I will just give 0, and also from 2 to 3 I do not have any connectivity, I will give 0. Now let us take 3. So 3 to 0 I have connectivity, I will give 1. I do not have 3 to connectivity with 1, direct connectivity with 1, and also I do not have direct connectivity to 2, and also I do not have connectivity to 3. So all becomes 0. So 0, I do not have direct connectivity from 3 to 1, and also 3 to 2 and 3 to 0. So this is how you construct an adjacency matrix from a given graph. So first what you have to do, you have to construct a table for V by V. V is nothing but vertices. See how many vertices are given, that many columns and rows has to be created, and then you have to see that is there any direct connectivity from I and j. If there is direct connectivity, then you have to give that A array I j equal to 1. If they do not have any edge direct connectivity, then you just give 0. Only 2 values are possible within the 2-dimensional array, the adjacency matrix array, only 0 and 1. Okay. So this is how you have to create an adjacency matrix. Okay. Now we will see like adjacency list, how to like as a linked list, how to represent a graph by using a linked list, that is called as an adjacency list. We see that now. Okay. So in the last topic we have seen adjacency matrix, how to construct an adjacency matrix for a given graph. Now let us see how to represent an adjacency list from a given graph. Okay. So the array can be like, the adjacency list represents a graph as an array of linked list. Okay, I can say that array of linked list, we can represent this adjacency list. So here the index of the array represent a vertices. Okay, whatever the index, okay, we have in the graph, it just represents the vertex. Each element in its linked list represents the other vertices. Okay, when we have a link, we will be representing in a linked list from the edges to the other vertices. So how to construct and how to represent the graph for the adjacent list. Okay, so we can just create or design or construct an adjacency list for the given graph. Now we will see like how to create an adjacency list for this graph. Okay, so first what we have to do, we have to create an index. So index is nothing but the vertices. So the vertex is nothing but it represents the array. So we will be like representing an okay, now we will just represent an index as the vertex. Okay, we have totally 4 vertices. So we will be like drawing 4 indices. So we have 0, 1, 2 and 3. So these are the vertices. So we have 0 here, and we have 1, and we have 2, and we have 3. So from the graph we have to take all the vertices and we have to create an index here. Once it is done, now what we have to do is we have to create an adjacency list as a linked list. Okay, so you have to see that for 0, okay, for 0 vertices, what are the vertices which have the direct edges. So direct edges means that the adjacent vertex of 0. So adjacent vertex of 0 is 1, 2 and 3. So 3 we have direct edges. So you have to represent in a list. So what you have to do is you have to put an arrow mark. So from the index 0, we are just creating a list of adjacency vertex of this particular vertex. So we have, this is your data and this is your address, okay, of the other neighbor node or neighbor vertex. So for 0 we have 1, 2 and 3. Okay, so this is how you create a adjacency list from a given graph. Okay, so that's it. And the same you have to do it for 1. So what are the adjacent vertex of 1? So we have 0 and 2 and not 3, because 3 is not directly connected with 1. So we have only 2 list of nodes. Okay, so we will be like having 0 first and then followed by 2. Okay. So, this is the other adjacent vertex of 1. Okay. Again for 2, so what are the other what are the adjacent vertex of 2? So for 2 we have 0 and we have 1. Okay. So same like before, we can just give 0 here and followed by 1. And this is your 1. Okay. And now for the 3, the vertex 3, what are the adjacent vertex? Only 0. Okay. The other 2 is not directly connected. So 3 has only one adjacent vertex, which is nothing but 0. So that's it. This is how you represent a graph, or this is how you create an adjacency list for a given graph. So before, in the last topic, we have seen like how to construct an adjacency matrix. So matrix like when we have an the two-dimensional array V by V. So when we have the direct edges from I to J, we represent Aij is equal to 1. When we do not have edges, we represent that value as 0. But regarding the adjacency list, it's like we have an array of linked list. So the array is like all the vertices will be the index of the array, and the list is like created based upon the adjacency vertex of that particular index. For 0, what are the adjacent vertex, and for 1, what are the adjacent vertex? Adjacent vertex is nothing but where we have a direct link or direct edges from I to J or U to V, anything, any vertex. Okay, when we have direct edges, then that is called adjacent vertex. So for 3, only 0 is directly connected, 1 and 2 is not directly connected, but we have a path. We have a path from 3 to 1 and 1 to 3, all these things. They have the path actually, but they are not an adjacent vertex, they are not the neighbor nodes. So adjacency list is nothing but to give the all the adjacent vertex as the list. It's actually, it is very efficient in terms of storage. Okay, when we want to store the values, okay, when we want to store the values of the edges or cluster, okay, so whatever the adjacent vertex of 0, we can just directly like fetch all the records which is stored as a chained list in over here. Okay, so from when we have just assumed that when we have a millions of vertices, then this will be like mean a lot. Okay, how to store and retrieval will be more efficient when we have a more number of vertices, then that is where this particular benefits will be achieved. Okay, so as a small values, it is very like simple, but when just think that when we have a millions of vertices, how to store and how to retrieve in a efficient way. Okay, the adjacency list will be more benefited and more helpful in that regard. Okay, so that's it regarding your graph representation. So regarding graph representations and graph terminologies, we have covered in this video. The next video will see that what are the operations, ADT operations of graph, and how to do that operations, and what are the traversals of graph and algorithms of graph. All these things we'll see in the upcoming videos. Please stay tuned. Thank you. Happy learning.